Normally in a database, readers block writers and writers block readers. But with snapshot isolation, it takes that resource or that row, and the writer makes a copy of it, a snapshot of that row, and then the writer can work all they want to within their transaction. And while that's taking place, readers can continue to read from that row. When the writer commits, then the snapshot is written back, and life can go on. No blocking between readers and writers. Pretty cool. So this is snapshot isolation inside of SQL Server. We first turn it on by doing an alter database to set allow snapshot isolation on, and this turns on row versioning inside of the database. So instead of only using lock, SQL Server now has the option of using a snapshot of the row to isolate transactions. And if you further turn on the set read committed snapshot on, then at the database level, it will behave normally, meaning it will only read committed data, and this change is turned on database-wide, which is actually very, very cool, and it can help solve the readers versus writers locking and blocking problems for some databases. So let's go ahead and do this and watch and see what happens. I'll run these alter commands, but first I need to change out of Aesop's Fables in the second transaction. So the first transaction can get an exclusive lock on the database and change this setting. Great. Now we'll do the same basic test we did before, and we'll see the difference. Within a transaction, we're going to update Fable, setting the title for Fable number 2 to Rockin' with Snapshots. One row affected, and within this same transaction, we'll go ahead and look at it, and we can see yes, we now see Rocking with Snapshots. Normally, SPID52 would now have an exclusive lock on this row inside the Fable table. And if another transaction attempts to select, it'll be blocked, right? But with snapshot isolation on, we're going to come over here, switch to Aesop's database Fable, switch to the Aesop database, select title from Fable, ID equals 2, same row we're looking at, and we can select and we see the old data. Isn't that cool? Because it's selecting from the original row while SPID52 is working on that snapshot row. And we can come here and make another change, update it again, all within the transaction, see the change. Other people can come by and just view this all they want. As soon as we commit, now that change has taken place and the snapshot is copied back into the original row. One warning on snapshot isolation is that this puts a heavy load on TempDB because these row versions actually take place inside TempDB. So if TempDB was not your bottleneck already, because SQL Server 2005 uses TempDB heavily within the query optimization process, it will certainly be your bottleneck if you turn on snapshot isolation. So we looked at transactions, at the transaction log, we looked at locks, their granularity, mode, and duration. We saw how to observe locks using the activity monitor. We watched a deadlock and saw it visually using Profiler. Then we wrapped up with snapshot isolation, which really turns the whole locking and blocking issue on its ear, where now readers and writers don't block each other, but writers still block writers. So that's transactions.